Okay, we're going to talk about the liver. My husband eats liver, and I know what the liver does on the microscopic level, and I just can't do it. I can't eat liver. I can't even eat a bite of a liver, not a chicken liver, not a cow liver, nothing. And even if I taught him everything that the liver does, the man would still eat liver, like it's going out of style. So here's the liver, and we have two main lobes. We have the left lobe and the right lobe, and then we're going to have a falciform ligament between the two. And really, I'm just stalling while I try to get off this first slide really casually, but it's not working, is it? No. Okay, so here are the liver functions. Now, all these functions you actually know about because we've already done these over the past years, and I'm trying to get down to this last function. But now, the liver makes blood proteins like fibrinogen and albumin and the alpha and beta globulins. We've gone over these in the blood chapter because these are for clotting fibrinogen and the procoagulants. Albumin helps, keep blood volume up, and alpha and beta globulins are for transporting substances through the blood. These are all made by the liver. We know that the liver stores glucose as glycogen, and then if we want to break that glycogen down, then we can do that, and that's called glycogenolysis. So that's one function of the liver. And that the liver makes cholesterol, and that's the basis for steroid hormones. So we've learned about that in the endocrine system. Not so much about the liver actually making the cholesterol, but that's actually where cholesterol comes from your liver. And we've never really talked about the liver being the detoxification organ or the liver storing vitamins, but just know that that's part of what the liver does. You don't have to know that for this chapter, but you probably know that your liver is your main detoxifying organ, and you probably know that liver, if you eat liver, it's very high in vitamins. Why is it high in vitamins? Because it stores vitamins. Like it stores, you can think of glucose as a vitamin if you want, but your B vitamins and iron and good stuff like that, right? So it's because those liver cells actually store those vitamins, and the vitamins are coming to the liver through the hepatic portal system. It's going to drain from your small intestines. But here is the only digestive role of your liver. It's to make bile. So that's what it does. It makes bile. Those little hepatocytes, the little liver cells, make bile. So here's your liver, and this is coming straight from a cadaver. Tasty, tasty if you wanted to eat that. You've got a left lobe and a right lobe, and between them we have this thing called a falciform ligament. Hanging down from it we have the ligamentum teres, or the round ligament. And this is a fetal remnant. This is left over from the umbilical vein, and I'll show you that in an upcoming slide. This is the gallbladder. It's not staining very green here, but usually you can see the bile coming through that, and that's where we store the bile that's made from your liver. Notice where your liver is nice and protected, mostly from under your rib cage. If we turn the liver around and we take away the inferior vena cava, we can see where there's a nice sulcus where the inferior vena cava lays right there. We have two more lobes on the back of our liver. We have the caudate lobe, which is right here, and we have the quadrate lobe. Really, these are part of the left lobe of your liver, so they're not really significant in any way. They're just anatomical lobes. They're not physiological. They're not doing anything. They're just on the back of the liver. So we have the caudate lobe and the quadrate lobe right here. And here we can see the gallbladder on the back here, and here's that ligamentum teres hanging off. Now, right in the back of the liver, where we have the entry for blood vessels and the bile duct, we have the porta hepatis. The bile ducts are leaving, by the way. The porta hepatis is where we have like the hepatic artery coming in and the hepatic portal vein. We call that region the porta hepatis. All right, not much to see back here. So going back here, this round ligament hanging off, this is what we're going to focus on right here. Where did this come from, this ligamentum teres? If we look at blood flow through a fetus, here's the placenta. Pretend like this is you in the womb. This is circulation of a fetus. Not a newborn yet. This is in the actual fetus. Now, if you remember circulation of the heart in a fetus, blood flow through the fetus was a little different than it is in you, because when blood flows through a fetal heart, it's going to come in through the superior and the inferior vena cava into the right atrium, and then down through the right ventricle, and then instead of going through the pulmonary trunk and right through the lungs, because we're not going to be breathing in a lot of air here, a lot of that blood flow will be shunted up through here, through this region right here called the ductus arteriosus, through this little vein right here. So it's going to go right into systemic circulation, bypassing pulmonary circulation, because our fetal lungs aren't very well developed. They don't need to be, we don't need to send a lot of blood to our fetal lungs because we're not breathing air yet. So we have this ductus arteriosus that's open up. Now, after we're born, this ductus arteriosus is going to close up and become the ligamentum arteriosum. I know you remember that. Now, so there's that first region right there. First thing for you to remember. Now, when blood comes back from the lungs, it goes into the left atrium and then down into the left ventricle, and then it's going to go out through the aorta. And so we're going out through the aorta. Oh, I forgot to tell you about the foramen ovale. Now, the foramen ovale, if we can see it in here, I can't see the foramen ovale. It should be in here somewhere. Where's our foramen ovale? There it is, the little hole. Blood will be shunted through the right to the left atrium, so we can bypass. Another way to bypass this pulmonary circulation is through the foramen ovale. Now, when we're born, that hole will close up right there and become the fossa ovalis. So those are our two fetal shunts in the heart. Now, where is our baby getting its oxygenated blood? It's getting its oxygenated blood from mother through this red thing right here, which you would think would be an artery, right? Because it's receiving oxygenated blood. But no, this is actually the fetal vein. This is the umbilical cord, and this is our fetal umbilical vein, taking this high oxygenated blood into the baby. So this umbilical vein will become our ligamentum teres in us after we are born, hanging off of our liver. All right, so it's taking our high oxygen blood into the baby, and after we go through systemic circulation, the baby's blood is going to return into mother through two umbilical arteries. So these two umbilical arteries are taking the lower oxygen blood back into the mother's circulation through that placenta. And so that's what your umbilical cord is. So after the baby is born, that umbilical cord will be cut, and then baby will be free from mother. Umbilical cord will be gone, and everything closes up. Here is our ligamentum teres now. That'll be closed up. This is ligamentum teres. And so those umbilical arteries will become the median umbilical ligaments. Now, if we look at the microscopic anatomy of the liver, we have these six-sided hexagonal little liver lobules, and in the middle of each liver lobule we have a central vein. And on the corner of each little area, you can't see it here, but we'll have little portal triads. Little units of 3 tubules will have an artery, a vein, or a branch off of an artery, a branch off of a vein, and a branch of a little bile duct on the corner of each one of these little corners. And blood will be flowing in this direction towards this little central vein here. And all of this region in here, in the lobule, this is microscopic, these are full of hepatocytes. The hepatocytes make up the liver lobules, they make up the liver, and these hepatocytes are doing what liver cells do. They store those vitamins, they detoxify, they make the albumin and everything else, and they're making bile, they're doing everything that liver cells do. But the blood is flowing from these corners this way, and the bile that is made by these cells will be flowing in the opposite direction, flowing to the outside here, like this. So let me show you in the next slide. So here's an artist rendition of that last slide here. These are our liver lobules. So here's a portal triad that I was mentioning in the last slide. I don't think I got it across here. There's units of 3. This is a portal triad. Here is a branch off the hepatic portal vein. And this is a branch off of the hepatic artery. And this is a little bile duct. And these little cells here, these are hepatocytes. And so this hepatocyte here is busy doing what hepatocytes do. This is detoxifying. It's making fibrinogen, it's making bile, it's making cholesterol. It's a busy little cell. So you should do things to make your little hepatocytes happy. Like you should never take 2 Tylenol and chase it with a beer and then eat wild mushrooms. That's a bad idea, right? Because your hepatocytes are busy doing everything hepatocytes are doing for you, so make them happy as well, right? Okay, so busy little cells. Let's go here. These things are called biocanaliculi. The biocanaliculi are little hallways that collect bile. And they take the bile and they shunt that bile, like this is a biocanalicus, out to the bile ducts. And these bile ducts take all the bile that's been collected in this bile duct, and this bile duct, and this bile duct, and those bile ducts feed into, let's see if I have a picture coming up. All the bile ducts, all those little bile ducts you saw, are going to feed into this left and right hepatic duct. And then when that bile accumulates in there, it'll feed into the common hepatic duct and then into this bile duct. And then the bile just won't ooze out into the duodenum because of these sphincters here, this hepatopancreatic sphincter and these pancreatic sphincters. Make sure that the bile accumulates in here, and then we'll back up into the cystic duct and then fill up into the gallbladder. So all of the bile that's made here gets stored into the gallbladder. All right. Now, this little portal arteriole and portal venule that make up this part of the portal triad, this is a branch off the hepatic artery, and this is a branch off the hepatic portal vein. So this is bringing, these little red things are bringing oxygen-rich blood to all the hepatocytes because they need oxygen. And these little veins are bringing nutrient-rich blood to all of the hepatocytes. So the hepatic portal, don't forget where the hepatic portal veins are. Now remember that the hepatic portal vein is made from the superior mesenteric vein and the inferior mesenteric vein and that splenic vein merging together. And I hate to do this, but I'm going to do it because I know you all are in denial. Here we go. I'll lose my place completely doing this. But here's the superior mesenteric vein, and here's the inferior mesenteric vein, and here's the splenic vein. And they come and they merge to form the hepatic portal vein. And that takes blood into our liver. And so that's where the nutrient-rich blood is coming from. It's draining the small intestines. And so those little blue things on the portal triads are branches off this hepatic portal vein. Now, these are the hepatic veins. That's where we're leading to next. Now all the blood, this blood from oxygen-rich blood and that nutrient-rich oxygen-poor blood is going to flow through these capillaries here. And these capillaries are called sinusoidal capillaries. Sinusoidal capillaries are, or the sinusoidal capillaries are very leaky capillaries. And that's just a type of capillary that they are. They have very big fenestrated pores in them and they're leaky. And the blood flows inward from these regions past the hepatocytes to this region here called the central vein. And the central vein, all the central veins from these liver lobules will eventually flow into the inferior vena cava. But before it gets to the inferior vena cava, it's going to go into those hepatic veins that I just showed you. So these are leading to the hepatic veins which dump into the inferior vena cava. These are branches off the hepatic portal vein. The hepatic portal vein lead to the liver, and the hepatic veins lead out of the liver. So remember to keep those straight. Now notice these little purple cells here. These are hepatic macrophages, and they're also called Kupffer cells. The Kupffer cells are creeping around in these sinusoidal capillaries, and they're big macrophages. They're eating anything. There's another one. Eating anything that's coming from the digestive system that just shouldn't be there, bacteria, anything like that. So Kupffer cells are very prominent. You find them in the liver. I'm trying to see if there's anything else that I missed in this picture to draw your attention to. I think that's it. Now, the coolest thing about your liver might be that it has an awesome regenerative capability. If you were to take away a big portion of your liver, it would totally regrow. It would grow back. It could grow back a huge amount of your liver. Uh, there's the Titan Prometheus, and the Greek gods got furious at Prometheus because he showed human beings fire, and so they chained him to a rock, and I think it was either I can't remember. I think it was eagles or something would come down, some big huge bird. Doesn't really matter because you get the picture. Every single night, the big huge bird would come down and eat out his liver, and then it would grow back overnight. And then the next day, the eagle would come down and eat out his liver again because it would grow back. That's how you can remember that your liver grows back. Or you could just remember that your liver grows back because I told you, but I seriously doubt that you'll remember it just because I told you, right? Because I've told you lots of things, eh? But your liver has great regenerative capability. Okay, now about bile, the substance that your liver actually makes. It's an emulsification agent, meaning it physically breaks down fat, not chemically, physically. It is not an enzyme. And how it physically digests fat is through its bile salts and through its lipids. You know, like dissolves like, so its lipids really help here. And the lipids that are in bile are cholesterol, phospholipids, and triglycerides. There are also some electrolytes in bile, but what makes bile green would be this pigment here, bilirubin. And bilirubin comes from heme, which is from your blood. So when red blood cells break down, heme is picked up by the liver. By that point, it's bilirubin, and it's put in the bile. And as it travels through your small and large intestines, it converts to urobilinogen, which is more of a yellow pigment, and then eventually it converts over to the stercobilin, which is the brown pigment. Now, as the bile does its job in the small intestines, as it's traveling through the small intestines, when it gets near the ileum, in the small intestines, the main job of the small intestines is absorption, and one thing that gets absorbed into the blood are the bile salts. And everything that gets absorbed into the blood goes through that hepatic portal system right to the liver. And so one thing that goes right back to the liver are the bile salts, and the liver just takes those bile salts and puts it right back into the bile. So this is called our enterohepatic circulation. So it's just a good way to make sure that we don't, you know, these bile pigments, they go right out in your feces because, you know, we're constantly losing red blood cells. So we have a never-ending supply of heme, but we don't have a never-ending supply of bile. So we can recycle our bile salts, never-ending supply of bile salts. So we recycle these guys. We don't need to recycle our heme. Okay, we'll save the pancreas for the next lecture.